You know, for centuries, from ancient myths all the way to modern sci-fi, we've been obsessed with this one single powerful idea. What if we could create a machine that thinks, a mind made of metal and code? But this isn't just a story anymore. It's one of the biggest scientific quests of our time. Okay, let's dive in. But that brings up this huge, fundamental question. I mean, how do you even begin to teach a machine to think? Do you sit down and try to write a rule for every single decision it could ever possibly make? Or do you try something else entirely? Something a little more, well, human?
Before we get too far ahead, let's just make sure we're on the same page. At its very core, artificial intelligence, or AI, is really just that, intelligence that's demonstrated by a machine. It's this big umbrella term for getting computers to do things that normally require human smarts.
So, to build that kind of intelligence, you first need a blueprint. You have to have the fundamental building blocks that let a machine process information and actually follow instructions.
The very first ingredient is the algorithm. Now that sounds super technical, I know, but it's really just a recipe. Seriously, it's a set of instructions a computer follows step by step to turn some kind of input, like a question, into a desired output, like an answer. It's just like following a recipe to bake a cake.
And how does a computer read that recipe? Well, it uses the simplest language you can possibly imagine, binary code. Every single instruction, every photo, every piece of data, it all gets broken down into a long string of just 2 digits, zeros and ones, off and on. And what's wild is that all of modern computing, all of that incredible complexity, is built on top of that super simple idea.
So, with those building blocks in place, researchers hit this major fork in the road. 2 totally different philosophies popped up about how to actually get to artificial intelligence, and it sparked a debate that would basically define the entire field for decades.
And this led to 2 camps with radically different ideas. On one side, you had classical AI, which treats intelligence as just a set of logical rules, kind of like a game of chess. And on the other, you had statistical AI, which sees intelligence as the ability to find patterns, like recognizing a friend's face in a crowd. It was this deep disagreement about what thinking even is. So here's the crucial difference you have to get. Classical AI is what we call a top-down approach. You, the human, give the machine the rules. You program them in explicitly. Then you give it some data, and it uses pure logic to figure out an answer. Statistical AI is the complete opposite. It's bottom-up. You just feed it a ton of data, give it some learning tools, and it figures out the patterns all on its own to build its own model of how the world works. For the first few decades of AI research, we're talking from the 1950s all the way to the 90s, that classical approach was totally king. The whole goal was to painstakingly write down all of human knowledge into a gigantic rulebook. I mean, think about it. For a medical diagnosis system, programmers would interview doctors for months, trying to turn all of their expertise into a massive list of if-then statements.
And I love this part. Researchers had these great nicknames for the 2 camps. They called it the neats versus the scruffies. The neats were the ones who believed intelligence came from elegant, logical rules. Their AIs were clean, predictable, and followed strict math. But the scruffies? They argued that real intelligence is messy, it's complicated. They thought a truly smart AI should be more like us, able to learn and adapt, even if it meant being a little less predictable.
And while the neats had the early lead, here's the thing. The real world is messy. It turned out that trying to write a rule for every single possibility was, well, pretty much impossible. A new approach was needed, and the scruffies, they were about to have their day. This was the beginning of the learning revolution. This new scruffy approach became known as machine learning. It's a whole subfield of AI that's focused entirely on learning from data. And an even more powerful version of that, one you've probably heard of, is deep learning, which uses these super complex models that are actually inspired by the structure of the human brain itself. And this right here, this was the revolutionary idea. This was the whole game changer. We stopped trying to be teachers, programming in all the rules by hand, and instead, we became architects. We started designing systems that could learn the rules all by themselves. The focus shifted completely from programming logic to providing data. So how does a machine actually learn? Well, it's kind of like a 3-step process. First, you feed it a ton of training data, let's say thousands of pictures that you've labeled Apple. Then, you use validation data to check its work and sort of fine-tune its accuracy. And finally, you hit it with brand new test data that it has never seen before to find out how well it really learned what an apple is. Now, the engine that's driving a lot of this learning is the artificial neural network. And it's a model that's inspired directly by the billions of interconnected neurons inside our own brains. Information goes into an input layer, it gets processed through these hidden layers where all the patterns get identified, and then it spits out a result. This is the absolute heart of that scruffy approach, letting the network find the connections all by itself.
Okay, so we've gone through the history, we've covered the theory, but why does any of this matter to you? Because this learning revolution has taken AI out of the research lab and put it directly into your world, often in ways you don't even realize. Every single time you search for something online, there is an AI working like crazy behind the scenes. It's not just matching the words you typed. It's analyzing the connections between billions of websites to rank them and give you the most relevant, most authoritative answer it can find in a tiny fraction of a second.
Or how about this? You finish a show on a streaming service and instantly a new one is recommended. And it's actually something you want to watch. That's AI. These recommendation engines learn what you like from your history and compare it to millions of other people to predict what you'll want to watch or buy or listen to next.
But the impact goes so much deeper than just convenience. In medicine, AI is becoming this incredibly powerful tool for doctors. Machine learning models, especially deep learning, are now amazing at identifying diseases in medical scans, finding signs of cancer or issues in eye scans, sometimes even more accurately than a human doctor can.
And honestly, the list just keeps on growing. AI is detecting bank fraud by spotting weird transaction patterns. It's helping scientists figure out the ridiculously complex shapes of proteins to invent new medicines. It's powering smart farming to get more crops with fewer resources. It's the voice inside your phone's assistant. It's even being used to compose music and create absolutely stunning works of art.
So it's pretty amazing when you think about it. We started this whole journey by trying to copy human logic, one rule at a time. But we ended up creating systems that learn in a way that is, well, it's both inspired by us and at the same time completely alien. The quest to build a thinking machine started by trying to mimic the human brain, which leaves us with one final fascinating question. Where will its own path take it from here?